Okay, guys, welcome back again. So, how many functional programmers over here? Okay, then you have an amazing session now. Power of Arrow to build Android using Kotlin with functional programming by Monica. She's been working as an Android developer since 4 years. So now let us welcome her onto the stage. So we can start off.
So let us all meet a developer John who is new to Kotlin and wants to use Kotlin's functional programming features in his project. So how can he do so? Enter Arrow. So hello everyone, I'm Monica Kumar Jethani and I welcome you all to this session on leveraging the power of Arrow to build Android applications using functional programming. So I'm a polyglot programmer with 4+ years of experience in software development. My interest areas are mobility and AI. I read code, write code, and speak about code. And I was born on the same day when Java was launched. So how many of you have started using functional programming in your projects? Okay, great. So in this session, we'll be looking into what is functional programming, functional constructs of Kotlin, then introduction to Arrow, deep dive into Arrow's data types and type classes, more functional programming concepts which Arrow brings with itself, and sample Arrow apps. So functional programming introduces a declarative style of programming where you focus on what to do rather than how to do. It treats computation as evaluation of mathematical functions. So in contrast to object-oriented programming where you have state in your programs and object changes the state via methods, functional programming strictly avoids maintenance and changing of state. So a key concept in functional programming is pure function. So with pure function, like a normal function, you take an input, you give an output. But there are some universal selling points that a pure function has. It gives the same output for the same input at all times. At t equal to 1, t equal to 2, t equal to 10, you will get the same output for the same input. Then second point is an important point that pure function focuses only on the parameters supplied to it. It does not work on anything outside of the function. So you can see on the right here the sum function is pure function for these two reasons. So at any point of time, if I give a equal to 1, b equal to 2, I'll always get output 3 because sum function focuses on the operands which are provided to it. It does not work on instance variables or anything which is outside of the function. Okay, so there are many advantages of functional programming over object-oriented programming. So as you know, we create the application as functions, so the code becomes more concise, modular, it becomes easier to test, it is predictable. You know that at t equal to 1 also, if you give A1, B2, you will get 3. Same, you will get the result at t equal to 10 also. And it encourages safe programming by introducing constructs like immutability and pure functions. So functional programming is language independent, and any language which treats functions as first-class citizen is termed as functional programming language. Examples are Scala, Haskell, and Kotlin. So in such languages, functions can be passed to other functions, they can be returned from functions, and they can be assigned to a variable. Okay, so let us take a look at functional constructs of Kotlin. They are immutability, which means that state of object for an immutable object, the state of object cannot be changed, and we impose immutability by using val keyword in Kotlin. Higher order functions are name given to those functions which take functions as parameters or return functions. Lambdas, again a function being supplied to another function, but in this case the function being supplied does not have a name. Lazy evaluation, where the creation of an object is deferred until it is first used. Tail call recursion, so I hope everybody here must be familiar with recursion. So tail call is when the last call in the method is called to the same subroutine. And tail call recursion, tail call optimization is in Kotlin is when you have the last call as a recursive call. Extension functions, where you can extend the functionality of a class by adding more methods. Null safety, where you can denote your nullable types with a question mark after the type. Pattern matching, figuring out which variant to call depending upon the pattern or the type. Okay, so Kotlin, as we all know, it works on flaws which were there in Java, and it adds, it tries to improve them. So we all know, since it improves on an object-oriented programming language, it itself is an object-oriented programming language. So Kotlin is basically a fusion of object-oriented programming and functional programming. It's not a pure functional programming language. It does not enforce functional programming, and it does not support typed functional programming. So to fix all these, Arrow enters. Arrow is a functional companion to Kotlin's standard library. It was introduced in 2017. Latest release is 0.7.3. It is fusion of two most popular Kotlin libraries, Category and Functional. And you can get more information about Arrow at arrowkt.io. So Arrow comes with 3 data types. It has many more data types, but in this presentation, we'll be focusing on the 3 important ones, which is option, either, and try. So all of them are sealed classes. And option, as its name indicates, it is used to indicate an optional value. So option A, if it contains some value of type A, it will have value within sum. So if it has some value, it will be sum A. If it doesn't have any value, it will be none. So option can either have sum or none. So as you can see in the example, if we try to assign some value, sum and a string, we print it, so we get some value as output. So in that case, some value variable contains option value of type sum. Second example, empty value variable contains option value of type none. Then there is an important rule for option that if on a sum type, if you perform any operation, you will get the result. If on a none type you attempt to perform an operation, you will always get none as the result. So in the example you can see number is an option type of type sum. No number is an option type of type none. So when you try to perform an operation on an option type sum, you get a result. When you try to perform an operation on an option type of none, you get result as none. Second is when you get the output as none, there might be cases where you might want to assign a default value in case of none type. So there you can use get or else. So it provides an option to you where it provides you the flexibility to provide a default value in case of none type. So maybe value has type none, and then using get or else, you assign it a default value. So when you print it, you get the default value you supplied because it's a none value. Then there are a use case for option can be like we have forms in our application. So we mainly the mandatory fields are email ID, password, username. Name can be option. So you can use option data type to store that name in your code. Then we all know that when clause in Kotlin is equivalent to switch. So when clause has a default, so in default case you can use none, and for the remaining cases you can use some. So now we move on to the second data type, which is either. So as its name implies, either can hold either of the two values. So left hand side is used to indicate the exception case, and right hand side is used to indicate the happy path. So in this example, you can see a variable named right, and it is of type either. So left hand side is supposed to contain a string, right supposed to contain an integer. You try to, you assign an either right, And when you print it, you get the right. Then second case where you try to assign either left. So left, since it denotes an exception thing, you can send some, you can put some validation messages. So when you print it, the left part gets printed. So you can also try to put some default values. Like if you have right, you can just output, you can put the default value, and for left, you can, that is exception case, you can just output 0. So this is an example when you can use when to extract the values from either. Same way like option, you can use get or else with either as well, and here also you can supply a default value to the left side. So here you can see again we are using get or else to assign a default value of 0 to the left part which contains a known error. So use case for either can be displaying validation stuff. Like in our forms, we have email, phone, so we expect certain format to be there. So if the format is correctly followed, we can take that as input. Otherwise, we can display validation messages with the help of either. Now we move on to try. So try is like analogous to try, which we see in Java, C#. So try checks if the value exists. If it exists, it will move on to success path. If it fails, it will move on to failure path. So in the example, you can see that get quiz questions has a probability of failing, throwing an exception. So that is enclosed within try. So since it is enclosed within try, it might throw an exception. If it throws an exception, you can see the output as failure, and you get the exception line number and the name of the exception as well. Okay. So similar to option and either, you can also extract the value of try. If it is success, you find out the B part. So we have failure as A and success as B. So in case of failure, you can output a default value, which in this case is 0, and success you can find out the B, which in this case is A. Okay, so there's a function used known as recover, which is used to handle the exception if it is a failure. So recover against it takes the exception and it gives the value which you want to appear on the screen when that exception occurs. So here a runtime exception is thrown. So when that occurs, it outputs a value 0. And this can be done using recover. Okay, so use case for try can be like for catching exceptions, like we have divide. So we might not always be sure that the divisor will be non-zero. So we can enclose the code for divide in the try block. If the divisor is non-zero, we can output the result of division. If it is 0, then try can be used and it can redirect to the failure path. Okay. So type classes are an important feature of Arrow. They denote behavior. There are 3 type classes which we'll be focusing on in this session. It is functor, monad, and applicative. So functor is used to apply a function to a wrapped value using map function. So here you can see we have a function from A to B. We have a wrapped value f of A, and then we get a wrapped value f of B. So f is the function which transforms the wrapped value, and map returns the transformed value within the same context. So how does functor works? Functor takes a function and a functor, and it returns a new functor. So here you can see that +3 is a function. Then we have a functor, which in this case is option sum2. And it returns a new functor. So when we perform an operation on option sum2, that is +3, it will give us sum5. So sum5 is a new functor. It's again the wrapped value which is provided by map function. So in functor, first the value is unwrapped from the context. Then the function +3 is applied to it. And the resulting value is rewrapped in the same context. So this works fine for some part. Now there is a none part which option contains. So for none part, the function itself isn't applied. So you can see on the right hand side the code which uses option none, and it wants to apply function +3 on it. So the function does not get applied, and the resulting output is none. Then applying functor to an array. So for each of the array values, the function gets applied, and we get a new array of values. Then a functor applied to a function. So here we can see the functor itself is a function. So first we apply on the given value, we apply the functor. That is, the given value is 10, so we do +2. It gives us 12. Then we apply the function to it, +3, which gives us 15. Okay, then functor works with option, either, try, or all data types which provide an instance of functor with it. So here you can see add1, which takes a parameter of type kind. So all classes like option, try, which provide an instance of functor to it, can be used here. So you can see here when I give the concrete implementation of this with option and try. So for option 1, it performs the function +1, and then it gives the output as sum2. And then with try, when I give when I perform the same thing with try 1, so it performs a function +1 and it gives success of 2. So similarly, you people can create your custom functors, but they should follow certain rules, and rules are like composition and identity. So you need to keep those in mind while creating your functors. So applicative is used to apply a wrapped function to a wrapped value using apply. So here you can see the function a equal to a +3 is also wrapped in some value, and we have a wrapped value sum2. So we apply the wrapped function to the value sum2 using apply, and we get the result sum5. So how applicative works? We have a function wrapped in a context. We have a value in context. We unwrap both and apply the function to the value, and we place the new value in the context. Okay. So applying applicative to an array of values. So if we have the function multiply by 2 and +3, we'll apply it like functor. We'll apply it to each of the array elements, and we'll get a new list of array elements. So there is a concept known as applicative builder, where you compute over different option types to bind them, to perform some computation. So here in the example you can see we have a class named employee, which has 3 properties: ID, name, and DOJ. And we have variables of option type, different option types. One is UUID, one is string, one is integer. So they are used to hold the values for these properties. So we use applicative and map to map all these variable values to as properties of employee. So USP for applicative builder is that it preserves type information when computing over different option types, and once all the values are completed, callback is invoked. So it happens when the values are sum. If either of the values is none, it will give output as none. It does not work on none. So monads apply a wrapped value to a function which returns a wrapped value using flat map. So here we have a function named half. So half takes an input, and if that is an even number, it will return it will return its half. Like if it is 4, it will give sum2. If it is not an even number, it will return none. So half is a function which returns a monad, and we have a wrapped value sum3. We apply it to half using flat map. So since 3 is not an even number, half will return none. 4 is an even number, so half will return wrapped value, that is sum2. When we try to do the same thing for none operation, it will give none. As I already said that every operation will work with sum, it won't work with none. So how does monad work? Monad takes a monad and a function which returns a monad, and then it returns a monad. So you can see here that sum3 is a monad, Then the function half is a function which returns a monad, and the final result is none, which itself is a monad. So monad chaining is also possible. So you can see here half is being invoked 3 times for the value sum 20. So first time when half gets invoked, it will give sum 10. Second time sum 5. Third time none. Monad binding is a process which is used to combine different option types. So option types can be combined using flat map also, but the computation increases a lot of complexity. So to avoid that, we use monad binding. So in monad binding, bind method also internally calls flat map, but it does it in a performance intensive way. So you can see we combine the 3 option types with integer values, and the resulting after monad binding is also an option type. Okay, so there is a relation between functor, applicative, and monad. So all contributors of functor are possible in an applicative, and all contributors of applicative are possible in monad as well. So there are a few more functional programming concepts. First is function composition. Composition, as its name implies, you compose function from existing functions. So compose an infix function. Infix meaning you put a function name between 2 names, and it assumes there are left and right parameters which are supplied to that function. So compose function takes value from the right, applies it to the left, and keeps on doing it till it gets a final result. So here you can see there are 2 functions, even and greater than 1000, and compose works on them. So compose will first filter the list based on even. Second, it will filter the list, it will pass the result of that to greater than 1000. Then it will filter the list based on greater than 1000. Piping. Piping is reverse of compose. It starts from the left and keeps applying it to everything on the right. So in this case, this is the same example which was there for compose. In this case, it will first evaluate the list for greater than 1000, and whatever is the resulting, it will provide that output to even. Logical component, it works on a function which returns a Boolean type and negates it. So here you can see there is a function for those integers which are greater than 0. Then lesser function is based on the complement of the previous function. That is, it will find all those which are less than 0. So complement function is used to find the complement of a particular function. So then we have the list there. So when we output the list, we'll get all the numbers from 1 to 5 in greater than, and all the remaining numbers in less than. Memoization is a technique which is used to cache results of pure functions. As we all know that pure functions return the same output for same input at all times. So if we cache a memoized function, pure functions result, it will be beneficial for us. We need not perform the same computation many times. So memoized function, it stores the result of computation and the parameters which were supplied to it. So how can you integrate Arrow with your existing Android Studio project? You need to add the dependencies. So this is a list of dependencies which are listed at the GitHub site. Based on whatever classes and functions you need to import the appropriate dependency. Okay, so this is a simple calculator app which takes 2 operands, performs add, subtract, multiply, divide. So it was a use case where I could incorporate the data types concept. So here in add operation, you can also use monad binding where you are combining options of similar type. So here for divide, I have used the try data type because there is a possibility that divisor might be 0. So if the divisor is 0, I get the failure with the exception name. If the divisor is non-zero, try executes a success path and I get the value. Similarly, multiplication, everyone knows 2 into 1 is 2, 3 into 1 is 3. So anything into sum 1 will be the number itself. So multiplication, I have considered that case. There are many more cases, like if the value is 0, then the result will be 0. So all those arrow concepts can be incorporated into what we usually do. Then this is a simple app where you enter your email and hit the subscribe button. So here I've used the option type. So if the email entered is a valid input, I store it in the variable. If it is not a valid input, I simply store none. So in this case, further processing like adding the email to mailing list won't be done. So you can see when no input is provided, email input stores it at none. When input is provided, it is stored as sum and the value. Okay, then best practices when using Arrow for Android. So Arrow is a new library and Kotlin is also new to most of us. So we can start incorporating Kotlin and Arrow in our projects as much as possible and try to push side effects to single point. Also, we need to be very sure about the different concepts, that is the data types and type classes, their differences, and we need to make sure how we can model our project using the given concepts which Arrow has. So there are various projects ongoing and which are already being done using Arrow. So like Helios is a JSON parser for Arrow. In Kotlin, and that uses Arrow. Then there is functional validation, which performs form validation using either and try data types. So you can check the other projects at this link. So are you all ready to try out Arrow? Okay, that's great. So this is the end of presentation. Thank you, everyone. And for any queries, you can reach out to my Gmail ID. Thank you.